parentheses. And the brackets book all this together, making this the main operator. Does that make sense? Because in order of operation, you do these two, then you do the stuff in there, and then you would add these together in math, as well as here. That becomes important more when we get into the next module than it does necessarily in this one. Now, the other thing this does is that's kind of giving you a basic key, and we can do some problems. But the other thing it does is it also this chapter begins to introduce us to truth tables. And truth tables are almost like their own little thing. Okay? So I kind of talked about I sort of talked about the symbolization, translating the statements, which is important. But truth tables are basically the idea that, there's always a rule that, for example, if I have something like A is true, and then I have something here like not A, suppose this is something like A is, applesauce is yummy, right? And then bar A is applesauce is not yummy, right? Now, if we conclude that this is a true statement, then if somebody says applesauce is not yummy, but it's true that applesauce is yummy, then clearly they have made a false statement, right? Now, this is a value statement, and so you might be going, well, that's kind of confusing. But I mean, if I said, like, Al is 6 feet tall, and this says Al is not 6 feet tall, but it's true that Al is 6 feet tall, and somebody says he's not 6 feet tall, then they've made a false statement, right? But if it's false that Al is 6 feet tall, and then somebody says Al is not, then they've made a true statement. Does that make sense?
So how do the truth and false, do they go in a certain order? Like how this one's half of it's true and the other one's false?
Right. For the truth tables, I can get into that here in just a minute. But yeah, it is because this one's just because it's just one letter. The only option is true or false. So it's not real complicated. But if we get into a statement like Al is 6 feet tall and Bill is 6 feet tall, well, now we have two symbols, right? So A could be true while B is true. A could be true while B is false. A could be false while B is true. And it could be false while both of them could be false simultaneously. Now, the rule basically is the number of letters, the number of letters you have up here determines how many lines you're going to need, how many variations. And basically it's there's a mathematical n equals the number of letters. And then we have the rule of 2 to the power of n determines how many lines you need. Now you say, well, why? Well, if you have 2, so you have 1, 2 number of letters, 2 to the power of 2 equals 4, and that allows us to have every possible combination of truth and falsity. Does that make sense? If you have 3 different letters, like you were to have A plus B wedge C, then you have 1, 2, 3, so 2 to the power of 3, 2 times 2 times 2 is 8, right? If you had a 4th letter, triple bar D, you now have 4, so 2 to the power of 4 is 16, right? If you have 5, you need 32, then you need 64, 128, and I promise I won't give you any that need more than 512 lines, okay, on the set. And that's really tough, especially when you're trying, those boxes get off a little bit, and you have to get them all in there, right? No, I'm kidding, we won't. Anyway, but then you said, well, how do you determine what order to put those in? This is kind of getting a little bit into the next step. But, I think the book, let me look here real quick at which way the book does it, because I don't want to tell you one way. I'll try to tell you the way the book does it, but I always do it a way the book doesn't do it. So.
The book hardly makes sense.
Hi. Sorry.
Nice to meet you, Hassan.
What's that? Oh, Hassan, okay. So the book always starts off by doing whatever your first letter is as true, false, true, false. And then since you did one true, one false, one true, one false, the next one it always says true, true, false, false. And then since you did 2 and 2, then the next time you would do true, 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 false, 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 false. And so every time you double it. The only thing to keep in mind is that sometimes when you are doing these charts, sometimes you'll have something like A wedge, A horseshoe, B, something like that, which there's a whole thing, this is called tautology, it's kind of pointless. But if you were to symbolize that, you would make A true, false, true, false. But you need to remember that if A is true here, it needs to be true here as well. So you want to make sure that A matches on each line if you have the same letter in it. Does that make sense? Because you can use this for arguments and you will have the same letter. One thing to keep in mind is always make sure the letters, if used twice, match. And then B would be true, true, false, false. Does that answer your question, Chloe?
Yeah.
Okay. So, basically, just to go through these charts, because that's the other part of it, you have A plus B. Let's go ahead and do it in the same way they do it. They have true, false, true, false. And this is true, true, false, false. And suppose this is something like Al is here and Bill is here. Okay? Well, let's suppose it's true that Al is here and it's true that Bill is here. Then is it true that Al and Bill are here? Is that a true statement? Yes. But if the statement is Al is here is not true, but Bill is here is true, then is the statement Al and Bill are here true or false?
False.
It's false, right? Because any one of these letters being false makes the plus false. Either one makes the conjunct false. And so all of them are false because in this case B is false, in this case they're both false, so the combined sentence is false. And so the idea here is that the truth of the statement, the truth of the function, is determined by the truth of the parts.
Sorry, I had to work till 3.
That's all right. What's your name?
Keegan?
Keegan. Hi, Keegan. Okay.
Trios.
Okay. So that's the way the A plus B works. So then let's just go ahead and do A wedge B. I'm just going through the truth tables,
Okay.
and then we'll break up and do a few problems where. So this one you go true, false, true, false, true, true, false, false. And so in this case, if it's like Al is here or Bill is here, and both of them are here, then is it true Al or Bill is here? Is that a true statement? Yeah, because one of them being true makes the whole thing true. But if Al or Bill is here and it's only true that Bill is here, is that still true?
Yeah.
Yeah, because if I say something like, well, I'll be there at 3 or 3:30, right? And you show up at 3:30, you're still, you still made a true statement, right? Even though one of the disjuncts is what we call it, even though one of the letters is false. And so that's false. The only time the disjunct, the wedge, would be false is if both of the ones are false. Okay? So then we get into horseshoe, which is if A then B. All right? Fair enough. So if this is something like, if Al is here, then Bill is here. And it's true that Al is here and it's true that Bill is here, then is the statement if Al is here, then Bill is here, is that true? It appears to be. I mean, this is basically asking, is this statement, if Al is here, then Bill is here, is that a true statement? Well, if both sides are true, then we can go ahead and assume it's probably a true statement. We have no reason to believe it's not. Now, if it's the case that if Al is here, then Bill will be here, is it true or false if Al is not here, but Bill is? If Al is here, then Bill will be here.
That's false.
This is one that's a little bit tricky. It's actually true. And the reason why, and this is why it's a little bit tricky, is this is saying if Al is here, then Bill will be here. Right? Al isn't here, but Bill is here. So does this make it false? Well, we don't know. It's like saying if you are murdered, then you will be dead. Right? If you are murdered, then you will be dead, right? Fair enough? Now suppose it's false that you were murdered, but it's true that you were dead, right? But if you were murdered, would you be dead? It would still be true that if you were murdered, then you were dead. It's just, it's not true in this case. But the statement as a whole is still a true statement. So the fact that the antecedent is false and the consequent is true doesn't make the statement false. It's only if, on the other hand, if you were murdered, then you would be dead. If it was possible for it to be true that you were murdered, but you weren't dead, then that would be a false statement. Why? Because anytime this is true, this has to be true. And so if this can be true without that being true, then it's a false statement. Okay? And so this we assume is true as well. Now, is it the case that it's true all the time? We don't really know for sure. But for our purposes, we will assume it's true. So the antecedent being true, but the consequent being false, would make the statement false. Otherwise, we would assume it's true. Okay? And then, with triple bar, if we replace it with that, this one, in this case, the antecedent being true and the consequent being true goes back and forth. They're both true. But what happens is, because in this case, this antecedent is true, but this one's false, we know that's a false statement as well as this one. Okay? Now, there's two things to do with this. One is you can do two things with these truth tables. You can simply memorize them, and that's one way to handle it. The other way to handle it is to actually kind of understand. I think that you're better off to actually know what these statements mean, because if you're just like, I don't know, but I know that if this is false and that one's true, then it's false. You can do that and that works, but it's better off if you know, like, well, if this is true, then that's true, and then that being true and that being true, that makes it true. If you can understand that if-only-if relationship, and you can understand it in ordinary language, I think you'll understand it better. Does that make sense? So the thing is these tables we will use to do truth tables in the next module, but the key first thing is the ability to translate. So I'd like just to sit down and have us do some of those if that works for everybody. All right? So that was kind of my review.